honestly feels like a superpower to know how to build an app, to take something that's an idea in your head and put it on your phone.
And it's not just your phone.
There are over 2.5 billion Android devices in the world.
That's phones, tablets, TVs, watches, and even cars.
Imagine how cool it would be to make an app that your friends can use.
The apps that you use on your phone are often quite complex. They have whole companies and teams of engineers working on them. And all those engineers had to start at the beginning.
So in this course, we're going to focus on building a series of basic Android apps that can run on a phone.
The course is split up into units. Each unit is made up of several pathways. Pathways are composed of videos, code labs, and quizzes. And, drumroll please, you will earn badges along the way.
You'll also be building up your developer profile, which you can use to show the skills you've gained throughout this course.
By learning the fundamentals of programming and the core concepts in Android, you will have a solid foundation to build off of.
You'll learn how to use Android Studio, the tool we use to write our code.
And you'll be learning Kotlin, the recommended programming language for developing Android apps. At its core, a programming language is used to tell a computer what you want it to do. It's similar to learning a foreign language, but instead of speaking to people from another country, we're communicating with the computer.
We'll get into more details of learning Kotlin later, but first let's talk about what you need to start this course.
To get started, you need a computer and an internet connection so you can download Android Studio. You don't need any prior programming experience, but we do require that you have basic computer and math skills. Knowing basic math is useful when you are programming because of the problem-solving skills involved.
It's also helpful to have an Android device, phone or tablet, to test your app on. If you don't have one, that's okay. We'll show you how to simulate an Android device on your computer with something called an emulator. It's also great to be familiar with using Android apps. If you haven't used Android before, you'll learn this along the way.
Above all, the most important requirement is your motivation and willingness to learn. It's going to be a challenging but rewarding process if you stick with it.
You may be asking, can I get a job as an Android developer after this course? Well, the answer is not quite. We're going to prepare you with the basics, and there are more advanced classes you can take and more practice you should do on your own to pursue the career path of a developer.
Now, you might be asking, how long will the course take? That really depends on how much you already know and how much time you can invest in learning the material. Anywhere from a few weeks to a few months is realistic.
No matter where you come from, this journey will be challenging, interesting, and we hope also fun.
By the end, you will have built a collection of apps that will show you a glimpse of what's possible with Android.
We are super excited!
Super excited!
We're super excited that you've decided to join us, and we welcome you to this course.
Welcome!
Okay, that was a bit hard to watch, but okay. So I guess we could start off with, let's see here. Yeah, so this is the first one. So we can start off with building our first Android app. I'm not sure if we want to watch all these. Let's just like skim through it.
Welcome to Unit
I think
1,
like the
beginning of your
it's pretty
amazing
intuitive.
journey.
Like
In
kind
this
of-
unit, you will learn important concepts in Kotlin and Android development to get you set up for success.
Dive right into learning some basics in a programming language called Kotlin.
Kotlin is a modern programming language. It's efficient to write and has features that help prevent mistakes in your code.
It's rapidly becoming one of the most loved programming languages in the world, and we at Google recommend it for building Android apps.
In the second pathway, we'll help you set up your computer. We will teach you how to use the same tool that professional Android developers use to build their apps. It's called Android Studio, and you'll be installing that on your computer. Once it's set up, we'll walk you through how to create and run your first Android app. This is always a magical milestone.
In the third pathway, we'll make a birthday card app. You'll get to customize the app for someone special in your life and surprise them with it.
In the fourth pathway, we'll learn how to make an app that has an on-screen button that can be clicked. You'll write Kotlin code for how the app will behave when the user taps the button.
This will unlock infinite possibilities for the types of apps you can create.
Don't worry, we know it's a lot, but we'll be guiding you through the pathways, and we're confident that you can do this.
It's normal to feel overwhelmed with all this new information, so take it bit by bit. It takes time to learn and digest the material.
With each app you create, you will gain more confidence in the skills you are building.
Before we begin, let's double check that you have everything you'll need. You'll need a computer with internet access that you can...
we know that. And they said something about the most loved programming language. it's becoming the most loved program in Kotlin. That's definitely not true. I know Rust is like a little bit off topic, but definitely not Kotlin. A lot of people don't like Kotlin just because it's based on Java, and Java has its problems. But anyways, let's start off with writing our first program in Kotlin. So again, I sent the link. If you need the link, I could send it again. But we're just following this kind of course, and make sure you sign in if you want like the badges. I don't. I guess I can sign in. Yeah, so I guess we can do that. Where was I? Oh, that was a video. Okay, so yeah, let's do that. Let's get our badges. Okay, so it says practice problems are optional, but let's do them anyways, just because it's a good practice. So you can see that Kotlin's pretty basic. There's just a main function. FUN stands for, or it's short for function. And then you have a main, kind of like every other object-oriented programming language. And yeah, you'll get that output if you put in this input. They have a website. I think it's kotlinlang.org. Okay, yeah. And you could, if you just type this in, I'll just send it in chat. You can just, you don't have to download Kotlin just yet, but you can use this as your kind of shell. So if you want to do like hello world in Kotlin, it would just be println hello world. And if you press run, yeah, you get hello world there. So that's pretty much like the basic print output with Kotlin. It's very basic. Let's see what else they want. So yeah, you can use the \n. If you've used other programming languages, it's very similar. I'll just do it just for the sake. New line. So the \n escape character pretty much just tells the compiler, hey, new line here. And so you'll have a new line if it wants to do that. Okay, maybe not. Maybe it doesn't like that, but you understand. It'd be the same thing as doing this too, which I think you saw. LN, and then just a new thing like a new line. So yeah, so that previous it just did that, and then if I do this again, it'll do the exact same output. So just two different ways of doing things. Let's see what else here. So yeah, I think these all done. Oh, we were supposed to go through these. Okay, my bad. Okay, sorry. Let's go back to where we were. All right, let's follow this. I just kind of skipped over. I don't even know how I did that, but I must have just clicked on stuff. So you can use an interactive code editor. This is the one that they recommend, I guess. It's literally the same thing. I'll just send this one. And you could follow what they say. So to hello world, just like what I did it in that other compiler or that other website, you'll get that output. It's a lot of writing for such little. But if you have any questions on how this works, yeah, just let me know, because I think this is pretty basic. I think we would move forward. So I guess we can modify our program now, and we can change the program to say something different, like happy birthday. Because again, the final goal in this project from that video was like, we're going to build our own happy birthday card. So we're going to design like the UI for that. So I guess this is a good start, even though you wouldn't really, in an Android app, you're not going to see your console output unless you're like a developer debugging your application. But I guess they just want us to practice here. So again, so they talk about like the functions. How does it work? You can understand that FUN, the keyword, is a word in Kotlin programming language. Fun stands for function, so it's just a shortened version of that. The main is the name of the function. So every main is like what gets run, the main thread of your application once it gets compiled. The parentheses pretty much means, or the two parentheses after the definition of your name is like your function definition. And then you could also have arguments within here, but I'm just intuitively just thinking that there are no arguments in your main function unless you're doing something else. But for something like this, you don't really need arguments. What arguments are, I'm not actually sure in Kotlin, but pretty much you can change the parameters of your function execution. I don't think we're gonna do that. So I'm just kind of spewing my mind here. So you can see that printing something out is as basic as print ln. And if you've done any other programming language, this is going to be very unbearable to hear because I'm just saying that. But if you've never done a programming language, I'm sorry if I'm going really fast. I just kind of assumed that. But let me reiterate. So you have your main function here, fun. This is in blue. You can see. Yeah, it's in blue. And then you have your main, which is your keyword. If I were to do like test, this wouldn't work because you need a main method. So you can have function like main, and then you could like do whatever you want in here. I'll do print ln, so print line. This is my main function. And then that would work, right? But then this code would just be irrelevant. So I'm just assuming you can do functions like this. And if you were to call your test, if you were to invoke your test method or test function within your main method, it will actually execute and print out hello world. So I'll say like hello inside my test function. Yeah, I guess that's how that works. And I didn't really know that prior. I just kind of assumed that you can define functions like that and run your code within other functions, and it'll work like that. So you can see that this is my main function runs first because it seems like it runs top to bottom. Well, I mean, everything kind of does like that. So this will run first, and then this will run second, and then it'll go back up here and it'll execute this line just because you invoked that function here. So that's pretty much basics. That makes sense. Hopefully it does. If it doesn't, please interrupt me. Yeah, you can print out happy birthday just like that. Let's extend our program. So I guess you guys can do this for yourself. So like, excuse me, you would do like your name and then your age. You guys can do that. Yeah, and you might get errors, right? So the error here, I think they say it. It thinks this word, this person's name, is a variable because there's no quotes around it. So if you like get rid of, if you already get rid of this, you're gonna get some syntax errors because it doesn't know whatever you put in between quotes is a string. That's what you call it, a string, and it's a primitive data type. You find it in everything. So a string is just a sequence of characters, right? But if you do something without strings, so like let's say I want to say hello world, right? It's not gonna know what you're talking about. It's gonna think this is a variable, and we'll get into variables probably later on. I'm not sure, but again, it thinks that keyword is already defined. Obviously, it's not. We just want to say hello world quite literally, so you put it between quotes, just like that. So that's the error with this problem or with this kind of slide. And so you guys can do this for yourself as an exercise. I guess I'll do this myself, just so we're on the same page here. So I'll do print ln happy birthday, print ln, oops. And then I want to say, what did they say? Oh, your name. So my name is Zavaar. And then what does it say? You are 25, so that's probably my age. So you are, how old am I? 19. And so just like that, you should get that same output. So you guys can do that for yourself as a practice, just to get yourself familiarized with Kotlin. Let's see the summary here. So yeah, all Kotlin programs need to have a main function because remember, when we did something without a main function, it gave us that error, if you remember. And then if you want to print a line or print line, this function prints a line of text. And then you want to make sure you place what you want to print between double quotes, because remember, that's how you're telling the compiler or what evaluates your code. Hey, this is a string. I want to literally print out hello and not a variable or not some other reference. And then you want to repeat your print line to obviously print multiple lines of whatever you want. And if you have errors, your code editor will tell you. That's pretty much it, I guess. Practice on your own. I think we had enough practice. I don't know about you guys, but yeah, you can also add these \n's. I think I went over that, but if you put a \n, you'll have another space or another line. So you'll see that this line is empty here. And you can do the same here. So you can kind of pad your output just like that. I guess that's it. There's also a quiz. We do this. Can we just write a birthday message? Let's see. Okay. Okay. I didn't even realize. Okay, so let's do this. So we got to write a birthday message. I guess we kind of already did that, so we'll just skip over that. Add a birthday cake. This is really annoying, so I'm just going to copy it. But pretty much, you can see that everything prints out kind of line by line. So you'll see that what this looks like is literally what's going to print out, just because of the way the characters are organized and the offset are kind of balanced. I'll tell you what I mean by that. So if I were to just print this out, right, even though like you'll have a weird indent here, like it'll print it out, just because remember the Kotlin language is only going to print out like what's between the quotes, not between your code, right? This is like your standard output. This is just the output of your program. So if I were to remove a space here, it would obviously look a little offset. So those candles, or I guess the commas represent fire, to just be a little offset. So yeah, I guess that's pretty much as basic. And then you could actually combine this all to be in one. So what you can do, that'd be so annoying. Here, I'll just do it real quick. If I were to just use the \n method and copy each line for what it is, like so. Forgetting the end. Try to do that, and then \n, and I'm going to copy this, and then \n. So \n, remember that's new line, and then paste that in there, and then \n. I can get rid of all of this. This wouldn't actually work. I just realized we'd have to replace. Yeah, so now we have the spacing there. The spacing is very important, and so theoretically that should work. It should print out the same thing. Yeah, so it prints out the same thing because remember, we're actually saying a new line. So all of this entire string evaluates into this pretty much. Just think of it like that. Let's move on now. And then you could also have comments describing what your code does with 2 slashes. So if you're familiar with like JavaScript or C++, Java 2, that 2 slashes or forward slashes, you can see that that's just a comment. You'll see that it's grayed out. This is pretty much what your compiler ignores. So the language is not going to evaluate what you say here. So if I were to do /println this message, it's not going to do any. It's just going to print out the cake because that's the only thing we have. If I were to get rid of these 2 forward slashes, now you'll see that it's not great and it'll print out this message. So that's pretty much how comments work. Comments are mainly used to like just say what your code does. So I'll just have like these pointers up here saying like this prints out my cake. And pretty much like maybe like you as a developer might know what this code does, but comments are really helpful because let's say you give your code to another developer and they're looking at this like, what the heck does this do? Like maybe you know, but the developer doesn't, right? And so if you have like a comment here, that other developer will kind of be more in sync with what you're doing. So it's just a good way to kind of be consistent. It's a good practice to comment code. Yeah, so I guess you guys can do this too. Just print this out. I guess I'll do it too. I'll just follow along here. Print ln happy birthday. I'm not gonna do it word for word, but you can see that it works. Whatever. Yeah, so you can get a birthday message just like that through the console. Let's move on. So create and use variables. So I guess, yeah, so like we were doing before, right? Okay, I'm just gonna look at this real quick. All right, let's see. So let's clear this out. Let's declare our main function. So to declare or to declare your variables, you do like value, which is a keyword, just saying that, hey, this value is going to be defined. So we have to set a keyword. So remember, like we were trying to do like print ln. We were trying to do like hello world. Remember, we were trying to do hello world without quotes. That's not going to work because it's going to think hello is a variable. So let's actually do hello message. Right, hello message. If I were to run this, it's not going to know what that means. So let's define the hello message. So val hello message is equal to hello world. And so now it's going to know what you're talking about. The program, the compiler is going to be like, okay, yeah, this guy, he's obviously referring to this variable because there's no other variable, or there is a definition of this variable explicitly defined right here. So it'll print out this message like so, and it'll work for other types. So I'll say like val my age. I'm 19, so I'm going to do that, and then I'll do like print my age is add a colon here, and then we'll do my age. Let's see if that works. I don't really know Kotlin, so I'm just kind of just seeing how it works. You can kind of append your value to your print statement. So what I did here was I just added the value 19. This might be weird because you have like a string here, right? A string, which is, remember, a sequence of characters within the double quotes. How can you add a string to a number, right? Because you can add like a number plus a number, right? That'll give you another number, right? How do you add a string to a number? Pretty much what it does, from what I've seen from other programming languages, it just kind of turns this into a string itself. So like try to do this. Pretty much like that definition is it turns this number into a string pretty much, and it uses that based on the context given. So this string right here will turn into, or this number right here is going to turn into a string and append itself to the string. So yeah, that's pretty much how that works. Another way of kind of using or kind of putting your message or your other variable, I mean, this will work too. Like if I were to do hello message, you can add your thing here and it'll say hello world and my age is hello world, just because we put that hello message there. It'll work on like appending, like adding can work on it can work on pretty much any data type, it seems like. Well, not all of them, but the primitives, that's for sure. There's another way of doing it that I saw. You can use templates, which is, I mean, that's what they're called in other programming languages. So you use like these curly braces. It says it right here. You put a $. So it's just like JavaScript, if you know what that. Put a $, and then curly braces, and then you could pretty much put any keyword in here. So I'm going to put my age because that's a keyword. That's my variable, my age. And you can see that it prints out my age is 19. This will work with like a lot of expressions. So like I can do 15 plus like 10. That'll be 25. It'll evaluate that just like that. Just because pretty much what you have is in between this curly brace and this closing curly brace, it'll evaluate the code within. So you can actually do like hello message plus my age. And then I'll say like message, and it'll do that conversion kind of implicitly. You can add a separate space. Well, not implicitly, it'll explicitly do it. But this is like a nested call, and gets a little complicated. I'm just kind of showing you that, hey, this is how the Kotlin language kind of works. So yeah, you can do mathematical expressions, and you can assign that mathematical expression to a number. So you can do that if you want. We did that with name. Yeah, I guess you kind of got the gist of it. Just the variables, that is. So if you want to see like the number of days you've been alive, like they did it in that example, do your age. I'll actually call this a variable. or I'll call it a separate, I'll make it a separate variable. I'll say my age in days. And then I'll call this my age times 365, so that you can see that if I were to print my age, and then I'll say like my age, right? And then let's add a new line, and then say like my age, or we can say like my age in days, and then we get my age in days, and it'll work just like that. So what we're doing is we're kind of using a separate definition, or the previous definition, within this new definition. You can do that with almost any language. It's not very special, but yeah, that's pretty much like how you do that. I guess we can move on now. Birthday banner, I don't know if that's necessary. It's kind of just more printing stuff. I think we got the gist of that. But if any of you have like questions, I know I'm kind of just running through, please interrupt. I don't mind. Let's see here. So so now they're going to talk about functions, which is pretty cool, which is kind of what we did already, but we're going to actually go through it now. So you see how like this code right here and this code right here is like the same. Pretty much like you can like shorten your code, simplify your code by making this repeated code into its own method. So it's a very good practice to kind of refactor your code, if you want to call it, and put this code, repeated code that is, into a separate function to which you can call later on. So if you can see right here, like they have a function called print border. They call this in here, and then instead of like doing it explicitly, instead of explicitly saying print line right here and print line right here, like that same redundant piece of code, you can shorten it and just call the function print border twice between this print statement. So this is really good, because if I were to I'm just going to copy this for a second. This is useful because, first of all, you have less redundant code. Your code is more consistent and cleaner. And also, like, let's say if I have this, let's say I want to change the border, right? Then I got to go through everywhere I call this line of code. I'm going to have to go here. Let's say I want to make the border like a ton of hyphens, right? A ton of dashes. Then I'd have to go here and change it. And that's really annoying. And I don't want to do that, especially once you scale your application up, that's going to take a while. So you could just do it here, and you could see that the border itself will change. Oh, well, that's because I forgot to call the functions. And then I'll just call that here. But you can see that there's a certain amount of modularity that is good to adopt in terms of like coding practices. So that's really good. So I guess yeah, you can also use repeat, which I didn't know was a thing, but I guess it just repeats code, right? It's just kind of like an iterator. So this will allow you to iterate your code. And so instead of print line, they're using print, because it seems like print just prints out like consecutively. It doesn't break your line. So if I were to do like print hello, and then print world, you can see that it's not going to be a new line. It's just going to add it into its previous output, just because you're not using print line, right? If you were to do print line, these will be in two separate lines. That's just a practice that they do. And you can see that this makes it a lot easier. Let's see. So they use the print border function, and they're using this character right here. So then what you can do is just say like print line, happy birthday, and then you could do print border, and you can see that it does the same way, but it repeats it 23 times. Oh, we should probably add a print at the end, just so it'll break off. Oh, you can't do that. Sorry. Line. Like that. Okay, yeah. So pretty much the problem with that, remember, is when you do print, the the output gets cut off, or there's no like new line. So you have to manually print a new line with nothing in it, and that'll just break it'll break the line into the next line. So that's pretty much how you do that. And this is actually easier because now you can just change the character. Let's say I want to do hash instead. You could see just by changing one character, you can change the hash. I don't know how arguments work. Let's see, like pattern. Let's see if this works. And then let's try like hash here, and then equal sign there. Oh, okay. I don't know how parameters work. Let's see. Oh, maybe it's just not like that. Okay. I don't know how this works. I don't know how about what's it called? Parameters work. I guess we'll learn later on. Oh yeah. So yeah, they actually fix that problem, and just like that, yeah, pretty much you can change it easily now. Oh, I guess. Let's see here. So yeah, they're getting into where they're talking about like using a function parameter. So what a parameter is okay. So you can see that Kotlin. If I were to search up Kotlin, oh yeah, I'll just go to this website. They probably have somewhere where they say it's like statically typed. Static, no, okay. Well, it's usually a selling point. Pretty much, it seems like Kotlin and Java are both statically typed languages, meaning that anything you kind of declare needs to have a value. So right here, you can see that, like if I were to make this into a variable, like val my message, this value automatically is implied that it's a string. So you don't need to define it. But so when you're using function parameters, you need to define the type that you're making it like into a string. So you can see that. I'll show you what I mean. So let me make this a lot better. So I'm going to call this like border, right? Just like how they did it. So border, that's the keyword variable, and then you're assigning it to a type. So you're going to make your border of a string type, right? Because like that's what you're going to use, right? So because what you're printing out is a string, and so now this would work. So I'll print out my message, and now you could easily like change your what's it called? Like change your keyword or your border easily just by switching that character on. And so what you're doing here, remember, you're just defining border as a variable. Now border now is defined as a variable within this function, and it has an explicit type string. So if I were to put in a number here, you're going to get an error because it's expecting a string. A number isn't a string. A string is like what's between double quotes. So let's try this code out. You should see that it works, and I can easily change it now with the touch of a button or just change of a character. And so that's how you do that. Yeah, and so remember defining, you have to define your parameter explicitly, like, or you have to tell it like what type it is. You can see that's followed with a colon. Let's see here. So they guess they do the same thing. And they fixed it. Good job. Yeah. Let's see. So yeah, it's easy to change it. Okay, so I guess they want to add a separate parameter. So let's make this like a challenge. So that's the border. I guess we can copy the border. We'll put this in our main. And now they want us to have another, like they want to, like how long you want the border to be. They want to like make that a function argument. So to do that, to add another argument, I'm pretty sure it's just a comma, and then like size, we'll call it. And then let's give this size, is it a number? I don't know how they define things. Forgot. I think literally they had it on their site. Again, I don't know Kotlin either, so I'm just as new as you are with Kotlin. Pretty sure it's integer. Is it integer? I know in TypeScript it's a number. I guess we can just guess and check. Integer, and then we want to repeat it. We want to throw in the size of our border right there, and now we have to give it a size. So I'll give it a size of 5. So it's going to repeat 5 times. And then you can repeat it 5 times. Let's make this an equal sign. Run that. Okay, it's not an integer. I think it's a number. Oh, it's int. Sorry. Yeah, so you can see that that's pretty much how this works. We just define a new variable within the print border, and that'll be a function parameter, and you can add that parameter into print border just like that. And you can make your border bigger now. So let's say, I wasn't using the border variable. So let's say like val size is equal to like 23. And then this will be our border. So instead of using this hash, I'm going to use the value border given by that previous problem. And then I'm going to use the val size. And you can notice that these are the same, this and this, like border and size within here, and border and size. It doesn't matter what you use. I can call this B and I can call this S. Just make sure that positionally speaking, you are consistent. That's very important, because the only reason this is relevant, the border keyword and border size keyword, and the size keyword here are relevant, is within the context of the function. So you make sure you're consistent with what you're calling it. We don't have to be consistent here. We just have to know what we're doing. But you can call it border and size. I'll just call it BNS just to show you that it'll work. Just like so. So if I were to run this, it should look pretty cool. Yeah, that's pretty long. It's way too long. We can give this like 2 or 3, I guess. You can see you have a cool design. It's pretty modular because now you have the ability to like change the parameters of your function really easily just by changing these 2 variables. Now, if I want to change, like instead of prior, you had to go in here and change it manually. Now your code is a lot more dynamic in a sense. So yeah, so that's what they're doing, and they're using the function parameters to throw it in there for it to work. So yeah, I guess we can move on. Create a lane. Okay, I think this is a little repetitive, but let's see here. I don't want to cheat. I don't want to look through the thing. So I guess we can try this out. So let's do that. What are we doing? So we're just building a cake with layers and candles. So let's break this problem down. So far we have the comma as the top layer, pipe as the second layer, third layer is equal sign, and then you have an at for the next 4 layers. I'm just gonna scroll down. You can see that, okay, so they print it out like this. They have 3 separate functions. So I guess we can do that here. I'm just gonna copy this. So let's see. So we want to define these 3 functions. So to do that, I'm going to call the first function just like they have it defined, and that requires an age. So age is probably the number of times that they're iterating. So this will be like candles. So this will be like number of candles, num candles. And this will be of type integer. And we're going to need another 2 functions. So I'll just copy these because they're pretty much the same. And cake top, I guess I don't really know what that is, like frosting. I don't know. Number of frosting. That doesn't really make sense, but bear with me. And then your cake bottom is age and layers. So you have, I guess we'll just call it age, and then we'll just use what they used, layers, and that's also an integer. Is it an integer? Yeah, they're both integers. Okay, so how do we go about doing this? Let's think here. So the cake candles, we're just going to use that repeat, right? So what we would do is like repeat eat. Oh my god! All right. Numb candles, and we just do print like the thing, right? So first we want to start off with like print. We want to start off with the space, right? Just to make it aligned. Right? Number of candles, age. Okay, yeah. Okay. I'm just thinking this through. So we have number of candles, and then I think they use candles as and I don't even remember. We're gonna need two because from the picture, a candle has two things. So it has the pipe and then the comma, which is like the fire. So we're gonna need two loops here, and that'll just be like the pipe here. And so at the end, remember, it'll think like you're at the same kind of height, or it'll think you're in the same line. So we have to break our line in between because, right, we have to go back, or like once we print out all the candles, now we have to print out the candle bodies. Sorry, once we print out all the candle fire, then we have to print out all the other actual body of the candle. So that would just be that. And then trying to think. I think that should be good. Yeah, so this is right here is just going to give us a space, because if you notice, there is like one space right here. And then there also is another space. And then, yeah. And then I'm trying to think. So it would be +2 when we do it here and the other things, because there's an offset between the cakes. So if I were to run print cake candles, let's see what that gives us. Yeah, so here are our candles. And then we also need to have a print. Actually, no, we don't. That's fine. So now we did our candles. Now we want to print our cake top. So the cake top is these equal signs. So it'll just be an equal sign. And what we're going to want to do is repeat. So repeat. We're going to repeat the number of frosting that they asked for, remember? So they're going to repeat that how many times, whatever they said. So it'll be how old you are, right? Cake top. Yeah, it's how old you are. So it'll be how old you are +2 because just because of the offset of the candles, because there's an extra 1 and there's an extra 2 right here. So I'm just thinking this through. And then what we're going to want to do is print, print the equal sign. And then that should be the cake top. Right? Yeah, should be. Let's see if we get that. Oh yeah, so every time we start a new cake, we should probably print. Every time we start a new layer, we should just break the previous layer. Or we could just end it. You know, that'd probably be better if we just do that. You have to break the layer because it thought it was a new line. So that's how that would work. And so now you have your frosting, and now you're going to want to do the cake bottom. So the cake bottom has 2 parameters. Remember, it has the age, which is an integer, layers, which is an integer. So this would probably be a nested for loop. So it'd be repeat the age. Age +2. And then we want to, so we want to print out this, we want to print out this that many times, right? We want to print it out how many layers. So you want to print out the number you have +2, like the number of ats, you want to do that +2. So it would be, well, so here, I'll just do it the easy way first. So we can print line at, actually, I don't think there is an easy way. You'd have to account for layers. So let's do layers. So we want to print out this many, we want to print this out layer amount of times. So however many layers is. So now we would need to do, for us to do it like dynamically, I guess, we want to do repeat inside of a repeat, which you can do. This is called a nested loop. and we would do age plus 2. And here we would do print. Also make sure you break the line at the end so it doesn't think you're starting at that same line you were at previously. And I did that at the cake top. So right here, it would break that line. So now I'm going to do the at sign. And then at the end of each at sign, we want to break our line so that we can go on to the next layer. Does that make sense? So you have layers. You're going to repeat age many times plus 2 just to get that offset. And then at the end of this loop, at the end of printing it out this many times, we're going to break the line so that you get left with your frosting or your the bottom cake layers. I didn't actually uncomment this. Let me see. So now you have your cake right here, which is pretty good. So if any of you have any questions, the nested loop can be a little tricky, but pretty much what you're doing here is you're having like this is like the same thing, given that this is a static program, meaning that you don't have that second argument, the age for the first argument. This would be the same thing as that, given you're not given age. So you could do that too, but they asked for like your age too. So you could print out that amount, that amount of frosting or whatever the cake bottom, just so it's consistent. So now you can see how easy it is to change your age. Let's say like I'm 5 years old and I want only like 3 layers. You can see how easy it is now to change your cake, and it'll be kind of dynamic like that. Hopefully that makes sense. Please interrupt me because I haven't done this before, so I'm very new to Kotlin myself, and so if I'm skipping over concepts, please let me know. I can copy this, send it in the chat too, if any of you are interested. Yeah, hopefully that makes sense. Let's see what they said. So they do the same thing. So again, I think I sent this to you guys. I can send it again if anyone wants. So what they're doing here is, yeah, they're doing the age plus 2. That's for the offset, remember, and then you print out your cake top. And then they do the same thing for the candles, where they have one loop iterating, or they have one loop printing age amount of times this comma, and then they print an empty line to break the line. And then they want another line, or they want to start a new line with that offset space to start with the new candle. And they're going to repeat it age amount of times to get that many candles. And so, yeah. See how they do the for loop. Oh yeah, so they do they do the loop within the loop, and that's the best way of doing it. Just so you could easily change it. And so I think I literally did the exact same thing. Yeah, I mean that's probably the best solution. So yeah, that's how you do that, if that makes sense. You're using a repeat statement inside of a repeat statement so that you can print your at, and then once you're done with this repeat, you print a new line. So if, let's say like you're at the first layer, like the first repeat iteration, you're right here, it'll print it out, then it'll print line, break that line, and it'll go on to the next line. It'll finish that, then it'll go on to the next line. It'll finish that, go on to the next line, and so on and so forth, if that makes sense. So I guess we can move on. This is the code that they used. I think it's the same. At least they wrote comments, which is always a good practice. Yeah, so that's pretty much it for that. Any questions before I move forward?
Don't be shy in asking questions. If you all are having trouble understanding, please speak up.
Yeah, for sure. Please interrupt. We're here to help. So yeah, I guess we can go through the summary. So the $ curly braces inside of a quotation lets you kind of print statements. This is called template strings. It allows you to, well, make your string into a template, so to speak. You can create a variable with the val keyword, like that. And then they talk about some of the primitive types of like in code. So you have a string, which is surrounded by quotes, an integer, which is just a whole positive or negative number, such as those. You can pass more arguments. I'll zoom this in. Yeah, so you can pass, what does it say? Yeah, you can pass more than one argument and you have to make sure you declare the type to which you're passing in those functions, remember, because you need to explicitly define what exactly you're doing, right? Because if I were to just put in like a string, like let's say if I were to make my age like hey, that doesn't make sense, right? Like this doesn't make sense to you because you think an age is a number, but like if this code was like redacted, if this code didn't run, it would work, right? But since we're putting this age variable into here, it's going to see that this is a string and be like, oh, hold on 1 minute, this is supposed to be an integer, and then it'll throw an error. And so that's very important, right? So it'll say type is a string, but it wanted an integer. So that's very important to make sure you're using the same data types. Yeah, so a repeat statement lets you repeat whatever you want for however many times. And you can also nest your repeat statements within each other, so you can get kind of like a matrix, like matrix in the sense that you can print out a two-dimensional thing. So yeah, that's pretty good. I guess that's it to that. We're done with that. So now we're done with all of these. We can take the quiz now. Let's take the quiz. Oh, I guess we're in the quiz already. All right, I guess we can do this together. I don't really care. So what is a program? Let's see. The most verbose one, I always look at that one because that's probably it. A series of instructions that a computer system executes to accomplish some action. Yeah, that's probably a program. A specific task, that's pretty vague. That can mean a lot of things. Like you could say a sequence is a specific task. A tool that helps you write Kotlin code. I guess that's one example of a program, but it's kind of a stretch, especially in the context, given that we're writing programs, that's kind of a stretch to assume that. A defined set of instructions that tells your computer to print happy birthday. That's another example of a program, but it's not a good definition of a program. What keyword is used to define a function in Kotlin? We know that it's fun, remember, because it's just a shortened version of it, but trivial. Which of the following do you need to create a Kotlin program that prints a line of text? So which do you need? So you need a main function for everything. A comment is not required, though it is good, it's not required. Curly braces around the instructions to the system. Curly braces around the instructions. I don't really think so. I mean, you do need curly braces around your function. Like, I don't think you can call like print outside of a function. I don't even think that'll run. Yeah, so it doesn't like that. So I guess that is required. You need somewhere to run your code, and that's usually in your main method, which is surrounded by curly braces. So I would say that is a requirement. Yeah, you obviously need the print function. That's definitely true. You need to actually call the print statement. These are more so requirements, but this is like the actual definition of like the print that lets you print a line of text or whatever. So I would say that those three things. You don't need a repeat statement. That's just if you want to make it cool or whatever. So what do you expect from this Kotlin code to do? It'll print 2 lines of text. It uses an argument array of string. I think that's like the default argument. If you were to look at like Java default class, or to just look online, yeah, you see public static void main string of args. So I'm looking at Java right now because that's what Kotlin is based upon. Java. It's a less verbose version of Java, I guess. And I think it transpiles to Java, so that's also cool. But you could see that it uses string args, so I don't think that matters, the fact that it has arguments here. I think that's for when you actually run your program. There's certain parameters that you can put in here to make your program run a certain way. And these are usually command line arguments for getting technical. But I think this will just print 2 lines of text just like that. So how would you modify this main function so that it prints a 6-layer cake for someone's birthday? So we want a 6-layer cake. So layers needs to be equal to 6. And then age needs to be 4. That's pretty obvious. Yeah. And these have to be both integer types because, well, we just did that problem and it require integers. Yeah. So which of these options correctly calls the function below and passes it valid arguments? So name needs to be a string. So we already know this one wouldn't work. Both of these need to be string, and then the last one needs to be an integer. So the only one where the first 2 are strings and the last one an integer is this one. So that's the answer. I guess we can submit. Yay. Okay. Let me know if you guys don't understand one of these, or please speak up or DM or whatever. But I think it was pretty simple or straightforward. If not, we can move forward and download Android Studio. Yay. Let's take up a whole gig of our hard drive because Android Studio is a massive program. It is an IDE. And if you have experience in downloading, I think they're called integrated development environments, they are very expensive on your memory. So be prepared to do that. It sucks, but it is what it is. So the second, let me go back here. Just want to make sure I'm on pace here. Okay, so yeah, so did we not do all of this? Yeah, we did. We did all of this. I don't know why it doesn't let me say that. I think you have to actually watch the videos, but we did the introduction to Kotlin. Hopefully you have a good understanding of Kotlin and how it works. Now we can create our first app. That's a bit misleading because now we first have to install Android Studio. So let's watch the video, I guess. It's only a minute.
In this course, we'll be using Android Studio on our computer to help us create our Android apps. Android Studio is what's known as an IDE, or Integrated Development Environment.
If this is your first time working with an IDE, you can think of it as being like a workshop with a lot of tools. These tools help you write your code and lay out how your app will look on the screen. It shows you a real-time preview of what your design will look like as you create each screen.
And similar to how Google Docs checks your spelling, Android Studio checks for errors in your code as you type. It also gives you suggestions to help you code faster.
And of course, as you create your app, you'll want to see it in action. Android Studio builds and runs your app, either on an actual Android device or on something called an emulator, a tool that allows your computer to simulate an Android device.
Android Studio is an IDE because it integrates multiple developer tools together, doing a lot of the heavy lifting for us. Without it, the development process would be much longer and it would be easier to make all sorts of mistakes.
As you create apps in this course, you'll learn how to use Android Studio and get plenty of practice with it. If you're curious, take a look at the linked Android Studio documentation.
Let's go write apps!
Okay. I guess now we have to install Android Studio. Let's see what they say. I'm just gonna skip through this. Let's install it. Verify if the system requirements. So if you're on a Mac, what does it say? You need to go to the Apple menu. I don't know anything about Mac, so I'm just reading this just like you are. Make sure it says this, or it says that your OS version is specifically that. I'm assuming this and above, and your memory is at least 16 gigs of RAM. Yeah, you're gonna need a lot of memory for this, just because it's a pretty intensive program. I guess that's fair enough. Let's see. I don't really think. Yeah, you're gonna need how much? What's it called? Storage. You're gonna need a ton. Give me 1 second. Sorry. Sorry about that. My cat was really upset with something. Yeah, you're gonna need some. Well, I guess we'll just install it, see what it does. I don't think we need to read all this. Who reads instructions? Am I right? So go to this website right here. I'll paste it, and you can download Android Studio. Yes, of course I agree to this. I just read it really fast. You didn't see it. Uh, let's see. So yeah, I got this badge that I downloaded. Android Studio. Where's it downloading? Is it going to download? Yeah, this is a very. It's probably going to take a bit just for everyone to download. You don't have to download it. I'm just telling you if you want to follow along, it would be ideal. There it is. Yeah, whole gig. So this is going to take a bit for myself. I don't know about you guys, but it will take some time for me. I guess we'll just let that. But if anyone has questions about the previous stuff, now would be a great time to say something because we're going to have to wait a bit for each and every one of us to download this. So we'll just wait. I guess we can see what we have to do ahead. Yeah, so you just go to that website, download Android Studio. I think you can figure out the rest in terms of downloading it. But this is going to take a bit, especially for me. My computer sucks. Okay, so my thing finished. Let me share my screen now so I can go over the yeah, so I'm gonna hit run on that executable that I just downloaded off this website. And for Mac, I assume it's like the same. They'll tell you how to go through with it. I'm gonna go through with this, and yeah, it's gonna use a lot of memory, which sucks. Yes, I want to install. It's a pretty straightforward installation process. All right, so I guess let us know if your installation you're getting weird errors or something. But for me, it's working fine. I'm not going to import any settings. I don't never use this. I've used this program, but not on this computer. No, I don't want to send anonymous statistics. Next, I'll do a standard installation. Of course, I want the dark theme. I'm not a psychopath. Next, accept. Make sure you read all this. I'm just really fast at reading. Yeah, and then you can finish, let it download. I guess this will take a while too. I don't know if my computer is just really slow, or I don't know if the installation process is supposed to take that long, but I guess we can just kind of look through it. Let me know if your guys takes just as long. Let's see, run an app. What just happened? I guess we'll just let this go on. Didn't realize it was that long of an installation process. I remember that was on my old computer, but it usually shouldn't take this long. I don't know. I guess I could just run through this while this does that, just so I don't waste you guys' time. So creating our first app. Once you have your thing installed, your Android Studio installed, it'll grant you with a entry, like a title screen, just like this. You click on New Project, and you can do, there's a certain number of presets you can do, and they're going to want us to do the empty activity, just for a basic kind of example. And here, I'll zoom this in. And yeah, you could, so I guess this project is going to start off with the happy birthday kind of title, the happy birthday app. That'll just kind of display like a birthday message or whatever. And yeah, just like that, you would just fill out the information just like this is. Of course, call it that. And this is like a discussion about your API level. And so what does it say? Yeah, so Android 4.4 KitKat. God, that was so long ago. I think that was like, what year was that? I don't know if it tells us that. When was KitKat released? (2013). So if your application, if you have your minimum software development kit, that's what SDK stands for, to Android 4.4 KitKat, it says it'll run on 99.4% of devices. And so that's just like a compatibility thing. Like if you write your app with a lower API level, you'll just have better, you have more reliability in terms of like application adoption and installation to work on older devices, which mean it'll work on more devices in general. The drawback, I assume, is just you can't use some of the new features in a higher API level. And so that's kind of a sacrifice you have to make as a developer. And so since we're building something as simple as like just a simple happy birthday message, it'll just be something, or it can be like as low as it needs to be, just because we're only displaying things. We're not, using our sensors on our phone and whatever API levels do that. But that's just, you can use a lower one just for something as basic as this. So I assume once you create your new project, you'll be able to, you make sure you use Android or use legacy Android support. That's unchecked. Whatever that is. I'm assuming that's just for legacy code support, which is something that is used in older code bases, and they want that to be unchecked for some reason. And then you'll be greeted with this dialog or this page, which has your directory or the directory of your project here. So that's like all your files and namespaces. And then in the middle, you have your actual code. So that was like for here, this is a code. You're gonna have your code right here within this IDE or code editor, whatever. And then on the right, you have I assume this is just like a welcome dialog, but your Android emulator app, like once you run your app, it'll be right here, and that'll be on the third screen. Yeah, so it says that right there. And yeah, I guess we can move on. I'll catch up once this downloads. I have no idea. I did not think it was going to take this long, so my apologies. I guess we can backtrack later on. So you can run your app on a virtual device emulator, which is pretty much like a fake phone that runs on your computer rather than on a physical phone. And that's good for development because, like I said in the beginning, you don't need like a physical phone. You can just use your computer. And that's good for a lot of developers because we don't need to carry our phone for something as simple as development. And so they have like a device manager where you can create and remove virtual devices. And you can see, you can select certain hardware. So these are all like phones that are commercially available. So this is the Google Pixel 5. It'll have the same specifications as the commercially available Pixel 5. And this is good for testing in certain environments, seeing if your app works in this phone, but not in another phone. It's really good that Google, or I guess Android, lets you do that for development. And you can get really technical with this. You can use certain images, which I assume is just versions of Android. Yeah. And you can create your own Android virtual device. I believe like the newer version like of Android Studio will let me, it'll just automatically have one. We'll see. And once you do that, you can press this play button right here and you can just run your application and it'll just be, where do they say hello world? Did they change that somewhere? That's weird. Okay, I don't remember them changing it. I'm assuming that's just a string that you change. Let's see. So yeah, so on the left, if you open up your folder that has all your project, this Gradle stuff, let me see, what is actually Gradle? It lets you package your applications. Let's see. So yeah, it's a build automation tool for software development and controls the development and process and task of packaging, testing, and deploying and publishing your application. And so that's pretty much how you build. I mean, you don't have to know this, but it's just the technology, if you understand behind it, on how to build your application. That's what Gradle is. Let's see here. So yeah, and this is on the left side of your pane. I'm sorry, my thing is still installing. You know what? Actually, I might have a working. Let me see if this works. I think I have Android Studio installed on this virtual machine. I might be able to show you because we are running low on time. So I don't think we're going to be able to get through this just because my thing is really slowed back. But it's not that big of a deal because pathway 2 or the section 2 isn't that long, so we can get caught up next session. So let's just see. So that's our directory, and then you can see the Java stuff. That's like the main activity. That's like your index file for your project. If this wants to load, I don't think this will actually work right now, at least. Just because I don't think that'll work, but yeah, it sucks. I'm sorry. But yeah, pretty much project files, which is on the left side of your screen. If you have it open, that's where that's where all the project files are. Uh, that's where your source code is, maybe some static files like pictures. Um, that's where your Java is, whatever, and also your Gradle scripts. So yeah, and I guess we'll go more into that once that installs. Yeah, I guess that's good enough. Oh, this was working. Okay. That just took a very long time. Okay, so I do have Android Studio here. So this is just a separate computer virtual machine. But I'm not going to be able to compile anything on here just because there's problems. Your computer needs to have virtualization, and by default it does. And there's ways to work around that. But this specific situation, this specific machine that I'm on right now doesn't have it on. So I will not be able to compile anything on here, but I can show you the UI and we can get situated with it real quick. We'll let that load. A lot of slow things we're dealing with here today. Yeah, so this will open up. Yeah, I guess I already have a project in here. Oh, finally. I think it's just finished. Okay. As soon as I figured this out, whatever. Okay, so now we can, for me, it just finished. So I'm going to go ahead and start with what we were doing. So they said, for the sake of the example, we just want to say hello world on our UI. So I'm going to go over to here, empty activity, click next, and we'll call this hello world. And I can leave everything else the same. I'll leave this the same too, Android Lollipop. Or I guess they wanted us to use a very old version. So this will work on 100% of devices, Android 4.1. I think they were using API 18. And then they want this to be unchecked. So this will, yeah. And so now it's going to download, do some more downloads, which is great. We need more downloads. And so that's going to download that. And then I shouldn't have closed out of that other thing. Okay, so that finished. Yeah, so this is the start of our project here. We're gonna give it a couple seconds for it to index. It says it on right down here. The JDK, or it's doing a ton of stuff. Just let it load, let it figure out everything. And you'll see everything will start to load real slowly. It's gonna do some downloading, which is great. And have this device manager here instead of the assistant. I clicked on this, and we'll be able to run our app soon, hopefully. It's still loading. But yeah, you can kind of see like this is the main activity.kt, which is like a Kotlin file. And you could see that it's kind of similar. Instead of a main function, you have a class. Kind of has some. I think this is like, I'm just kind of assuming. I don't know Kotlin. I'm just assuming that this is some sort of extension, some sort of polymorphism going on here. You have a base class, which is your main activity, extending off your main activity, and then yeah, extending off the main activity being derived from this method right here. And this method is imported from this module. And it's kind of complicated, but you don't need to really know all the intricacies behind it because I think this is just for like initializing your application. So once this finishes, we'll be able to see like our directory. I guess we already can't see our directory. Okay, yeah, I mean, that's all we need. So if I were to run, first let's take a look at our app and then source and main. I'm just looking through. This is the same file. Okay. I'm just looking through. Let's see what we can do with this. So these are some unit tests, which we will go into later on. But first, we're just getting used to this kind of environment. So this middle screen, we have our code. Left screen, we have our project directory. The right screen, I press device manager here. So I can run on a virtual machine or a virtual Android device. So I'm going to click this play button and launch a virtual device. But that's probably going to take a bit because it's very slow. Well, it's doing a ton of stuff right now. You gotta love IDEs because they're very slow. Sure, they're full of features, but man, it's insane. Let's see what they said. So they wanted us to create a device. We already have one because for some reason they just gave us one, which is a Google Pixel 3a. Oh, you can see it's finally loading my emulator. And you can see how resource intensive Android Studio is. Yeah, right here. It's using like 2 gigs of RAM plus counting. But you can see our Android phone starting to start up here, or it's starting up rather. Probably take a bit to kind of initialize. A lot of loading. It's pretty cool though. They let you do a lot. This extended controls. This dialog wants to open up. I guess not. They don't want to open it up. There it is. Okay. Yeah, so you can actually like change the location you're at. Oh my god, of course it freezes. This is insane. This is so slow. You can see it's starting up the QEMU. That's like a Linux virtual machine. Man. Yeah, QEMU, it's a way to emulate different kinds of stuff. So yeah, you can see it's killing my computer. But yeah, you can actually like put where you want. Did it finally load? No, it's still doing stuff. You can like change the location of the emulated device. So if I do that specific place and in my app, let's say like I go down the line and implement like a GPS feature, I can test it out right here. You can change the display. You can add a second display. You can change your cellular, like maybe you could make it like, let's say you're at a very low cellular coverage. You could make it like GSM, which is I think the lowest. It's very low. But yeah, you can change a single strength. Your battery. So you can see it's starting to finally load up. I can make my battery very low. I don't want to make it 0. I think it'll shut off, but I may have just done that. Hopefully not. No, okay. Yeah, but you can see like, I'm going to change it to, it's like half. Oh my God, of course I did it. Yeah, I accidentally put it to 0 and it shut down. Oh my God. All right. It shouldn't be as long just because, yeah, but you know, if you ever had your phone at like 0%, it's just going to shut off. That's exactly what I just did. And it's still indexing. This is so slow. I think it says how long you should be. Oh my God, my computer's freezing right now. I have no idea what just happened. My computer froze for a second. Yeah, you can see this stuff is pretty much like running a plague on your computer. It says you should wait. Forgot how long. It just says wait until it's or it's done. I think it's done. Okay, here's my Google Pixel 3 here. So it's incredibly slow. That is because of my computer. Yeah, it's starting to register. Oh, my battery's so low. Now it's at 19. It's not going to actually go down. It's just because I had it set to that. It's just so unbelievably slow. So I'm going to go to my battery and just put it to 100. You can see it changes like instantly. Back to 100. Oh my God, this is insane. Okay. All right. Well, I mean, there it is. I mean, there's your app, or not your app. I don't know why my app isn't in here, but it's probably because I never built it. But you can see like you have a fully functioning phone in here. Like I can go on Chrome. It'll probably tell me to sign in. Sure, of course. But it just works just like another normal phone. in the sense that like I can go to like YouTube and it'll just be like a normal phone. Oh, I guess not. I don't know what that is, but it probably doesn't like that. Yeah, I mean, my computer definitely does not like that. So I'll close out of this. I'll try to get our app on here. So let's see. So I'm going to press the run app button. And a lot of this is just trial and error, just learning how the IDE works. But let's see if it like pushes our app onto this virtual phone. Did it just do something? So I think, oh yeah, so it's actually running a Gradle build. So it's building my app right now. And this takes a long time. Yeah, they're very slow. Like app development is very slow, especially if your computer isn't that good. A lot of the previous app development that I've personally done have been like hybrid frameworks. So there's different kinds of frameworks you can write your code in. There's like Flutter Dart, which is a Google. It's a Google programming language that you can write mobile apps with, and it's fast, but it's fast in terms of like compilation, but like in terms of like you need a lot of system resources to run it. And this is only for Android too, by the way. And then there's also, oh my god, it's killing my computer. There's also Swift, which is like Apple's iOS's version of what's it called, of like app development. And this is primarily what Apple people use when they build iOS apps. And there's also hybrid frameworks, which is stuff that I've kind of done a lot in, like React Native. This is like a hybrid framework, is like you can write your app, but for like different kinds of platforms. So like I can write my React Native application, and this will work on an Android and iOS application. And it's pretty nice because it's based on React, which is a modular web framework written by Facebook in like 2013, I believe. It's a very nice library. But here our app is finally, after like 20 minutes. There it is, hello world. There it is, finally loaded on our virtual Android device. Now we're running out of time. Let me just change one thing. Let's figure out how to change that message. I would assume it's here, but it's probably, let's find out where let's find out where our static things are. So that's a test. That's our main file. Let's see here. Maybe it's statically defined. I have no idea. I mean, I guess I could just use this. So they pretty much, this is after they got it done. So it'd be learn the basic of Android tests. Is that it? Oh, okay. I guess we can just do this real quick. So we did this just kind of very slowly. Oh, so this is just Android debug. So if you have like an Android phone, you want to connect it, you can do right here, device manager, do physical, pair using Wi-Fi. And then you have to enable debugging on your Android phone. So let me try it. Let's see if mine works. I have it enabled, and that's in your developer settings on your phone. I'm gonna see if I'm able to pair it on my Android phone. So far, it's not working. Real surprise there. Yeah, and I'm up to date. So it's really weird. This sucks. Yeah, I literally just scanned it. It's not letting me connect. Okay, whatever. But you can do that if you want. We'll just move on. And you could also plug it into your phone, or sorry, you can plug your phone into your computer and let it debug from there. Yeah, so that's how you do that. And then, so we did that. So let's learn the basics of Android tests. So this is like, it seems like a summary of, what's it called? Test-driven development, or TSD, or TDS, test-driven, TDD, yeah, got it. Test-driven development. It's a type of development that relies on your utilities to work correctly. So what this allows you to do is, you can read that if you want. We're running low on time. So introduction to automated testing. So remember that folder we had, test folder? Forgot this is open. Yeah, here are our unit tests. So you have a function here. Remember we did stuff with functions, and you have an assertion. So an assertion is imported probably from org dot whatever this is. These are probably proprietary modules, but pretty much assert just make sure if like you get an error if like you have an expected value. So like let's say your actual value here, 2 plus 2 is equal to 5. You'll get an error here, and that's no good. Let's see how you run these. Can I run it? You have to build it over again. I don't want to build it. Okay, I guess I'll listen to the thing. So yeah, there are different kinds of, you'll see this a lot in software engineering down the line. Yeah, so you don't actually have to write any tests according to these guys. Let's just do the quiz. Okay, so what does IDE stand for? I don't actually know if they said it before, but it's Integrated Development Environment, I think. Which of the following are advantages of using Android Studio? Yeah, I guess it's pretty biased. It comes with virtual, yep. You can show your real-time preview how it look like. Well, yep. Not only, I actually don't know if that's a feature or not, but I assume it is just because they're probably trying to flex it or something. What is the minimum software development kit refer in an Android Studio project? So that's like, yeah, it's the minimum version of Android that your app can run on. Remember that was like that graph that they showed us, that like the lower SDK you had, the more users that can use it with older devices. What is the purpose of using a virtual device or emulator in Android Studio? To experiment app code safely. Yeah, you don't want to run dangerous code on your own personal phone, right? That's not good. I guess to test your app, not having that. Yeah, I guess that's probably a better reason. They're both pretty good. Yeah, I think this is a better answer, because like it's better to have an emulator than not. In Android Studio, what is the project template good for? Yeah, it definitely provides a structure. You can see right here, like it's pretty well organized how they have it. This is our structure, I guess, our project template. It is the only way to build apps that can be previewed. Probably, I'm not actually sure. It makes building a new app less. I have no idea. Less error prone by yeah, I guess that's fair. Yeah, boilerplate code is always good code. It makes getting started. Yeah, that's for sure. I don't know if it makes Android Studio download files faster. I'm not sure. I don't think that's we'll see, I guess. How do you create a new project? If you have a project already open, so it's probably B and C. So create a new file. No. Yeah, I guess you can do both B and C. Oh man, I screwed up. It's the only way to. Oh, I guess you don't need it. You don't need that. Okay, I guess that was just not true. They just put that there to trick you. I got tricked. Can you retake it? Of course. Integrated development environments. All these three. Minimum version your app can run on. This is a purpose. Yeah, it was to test without actually having your device. I already forgot this. I literally forgot. It makes, yeah, it definitely makes provides a structure. It is not the only way. Yeah, I think that was it. And then both B and C. Yay, I got the badge. Oh, I'm not signed in though anymore, whatever. Yeah, I guess that's it. We'll get into unit tests later. I thought they were actually going to make us write unit tests, but we don't need to. But I guess that's pretty much it, just because it's 6:30 now. Thank you guys for sticking around. Appreciate it. We'll move. I guess same time next week. We'll do this. We'll move on with pathway 3 and 4. We'll build our application forward, and what are we gonna do? We're gonna build our application. It'll be a happy birthday cake, which is like a front end thing, just designing our app, and then once we get situated with that, we're gonna build a dice roller application, which will be more involved with the code probably. Yeah, that's pathway 4, and so you can move it forward if you want. You don't have to stick with the pace that we're at. I know this was a slow day just because downloading Android Studio is pretty. It sucks, but yeah, thank you guys for sticking around. That's all I have. Yeah, I guess any questions before we depart?